In this video, we're going to be looking at points and an inequality and determining if that point is a solution to an inequality. And we have two ways of doing this. We can do this graphically by looking at the location of the point on the graph of the inequality, or we can do this algebraically by substituting the ordered pair into the inequality expression. So let's look first at the example of y is greater than or equal to negative x plus 5. We're familiar now with the process of graphing this. I graph the boundary condition, the area where negative x plus 5 defines our y value, and I would leave that as a dotted line, and then I shade in the appropriate areas. So in this case, the equals to condition, which is shading in the line, and the greater than condition, which is this part that is shaded in red. So now what I can do is I can take any point I like, let's say the point 1, 2, and I can determine if that point is a solution to the inequality y is greater than or equal to x plus 5. And I have two ways of doing it. Graphically, all I have to do is look and see if the point is in the shaded region. So in this case, that could mean on the line or above the line. But as we see, the point is not in the shaded region, so we would say the point 1, 2 is not a solution to the inequality. However, we can also do this if we don't have the graph. So just taking the inequality y is greater than or equal to negative x plus 5, what I can do is I can substitute those x and y values in and see if it creates a true statement. So in my expression, where y is, I replace it with a 2. And where x is, I replace it with a 1. And on the right-hand side of that inequality, I can simplify. I now have negative 1 plus 5, which is 4. So I end up with the expression 2 is greater than or equal to 4, which we can see is absolutely not true. Now, if I want to look at a more common sense way of doing this, which is never ever a bad idea, what the expression literally means is that whatever the y value in the ordered pair is, it's got to be bigger than negative the x value of that ordered pair plus 5. So the x value in this ordered pair is 1, so if I take negative 1 plus 5, that's got to be 4. So whatever my y value has to be bigger than 4, and we can see that that is plainly not the case here. So there's my two ways of doing this. Graphically, is it in the shaded region of the graph? Or algebraically, I substitute it back in and see what I get. Let's look at another point now, negative 1, 7. Graphically, I check to see if it is in the shaded region, and bingo, it is. It's in that area that's shaded red, so we can say that this is a solution. So what we'll notice then is that when we try and do this algebraically, we replace the y with 7, and the x with negative 1, and then we simplify again on that right-hand side. So here I would take the opposite of negative 1, which is positive 1, plus 5 would be 6. And so my expression ends up being 7 is greater than or equal to 6, and it's true, hot dog, this is a solution. Remember, a solution just means it makes the statement true. So I can see that that is plainly the case here. One final point for this particular inequality is if I look at the point 0, 5. Graphically, I can test to see if it's a solution by seeing if it lies in the shaded region. And notice that this is right on that boundary. So it's right on the line where all the y values are equal to that. But that is a shaded region. We did shade in that line, so it is in the shaded region, and 0, 5 is a solution. Algebraically, substituting in the 0 for x and the 5 for y, I see that on the right-hand side I would get negative 0 plus 5, which is 5, giving me the statement 5 is greater than or equal to 5. Well, that's true. 5 is equal to 5, and so this expression comes out to be true, and 0, 5 is in fact a solution. Next up, we're going to look at a quadratic. So here you see the graph of y is less than negative x squared plus 3x minus 1. And we're going to pick 3 points to test out on this one. First one we're going to test is the point 2, 4. So algebraically, we're going to substitute in a 2 and a 4, 2 for x, 4 for y. The left-hand side of the inequality is pretty straightforward, it's just 4. Right-hand side, however, needs a little work. We've got some number crunching to do. And so here we find that we get 2 squared, which is going to be 4, and then I make that negative, so negative 4 plus 3 times 2, which is 6, so that gives me positive 2, minus 1 would then be 1. And so I end up with the expression 4 is less than 1. Well, that equation is plainly not true. 4 is bigger than 1, so this thing is not a solution. If we were to look graphically at this, we would have known that already, because that point does not lie in the shaded region. So we can do this again with another point. Let's look at 2, 1 this time. So what we're looking for is to see if this is in the shaded region of the graph. Notice it is right on that boundary line in between my 3 sections. So the question is, did I shade in that line? And because this is y is less than negative x squared plus 3x minus 1, I did not shade in that. So even though it's close, this is not a solution. We can verify that algebraically by substituting in 1 for y and 2 for x. And when we do that, what we're going to find is that we get the expression 1 is less than 1. Well, that's not true. 1 is equal to 1, and since it's not true, it can't be a solution. And then finally, we're going to look at the point 2, negative 2. Graphically, I can see that this does lie in the shaded section of the inequality, so it is going to be a solution. Let's check that algebraically. If I substitute in negative 2 for y and positive 2 for x, I simplify the right-hand side, and just as we've done with all these others, it simplifies to 1. So I'm left with the expression negative 2 is less than 1. Well, that is plainly true. Negative 2 is indeed smaller than 1, and so we can see that that statement is true, and the point 2, negative 2 is a solution to the inequality. Practice hard, my friends. Be ready to use whichever of these techniques makes itself available. Sometimes it'll be easier to use the graph, sometimes it'll be easier to substitute the values in. You are responsible for knowing how to do both. Good luck.